Hello guys, my name is Arun Tyagi, and today I'm going to talk about one of very important service which we need in almost every product which is like consumer facing, where you have the users, number of users. So notification service, and in fact this is a very frequently asked design question in companies like Amazon, Google, in fact, and Microsoft. Let's start about this service. So first, let's cover the functional and non-functional requirement of it. So in functional requirement, basically the most basic and the important one is your service should be able to send notification to user. Then second is basically your service should be able to prioritize. By prioritize I mean, for example, you have notifications like sending an OTP, so obviously sending an OTP should be higher priority. Then if you have something like transactions, right, those can again be high priority notifications. Then you can have things like if you are sending promotional notifications, right, in that case those can come at a lower priority, means it's okay if they reach a little later to your users, right? So prioritization should be able to this service should be able to handle that. Then obviously there will be different modes, right, like you want to send SMS to your users, or you want to send emails, or you want to send, in fact, on WhatsApp, right, message directly, or things like in-app, like if we are watching match on a Hotstar, or if we are having a Hotstar app, and if today Sri Lanka and Pakistan final is happening, so Hotstar can send notification to the relevant users whom they feel should that they can watch match, if you will notify them, right? Then you should be able to, this service should be able to do rate limiting. By rate limiting I mean, it should not be like Zomato is sending 10 notification to me in a day that we are giving 50% off, or 10% on these kind of restaurants, blah blah blah. One or two notifications in a day is okay, right, but you cannot bombard a particular user with multiple notifications, then it will be a very bad user experience, right? So your service should be able to take care of that requirement as well. Then you should be able to send bulk notification also. By bulk notification, like I just give an example, if a match is about to start, so 15 minutes before match, you can send from your user base. You will basically, you already have a category of users who watch cricket match actively on Hotstar, so to all those users, if they are not online, you can send upfront a notification that match is about to start, get ready, things like that. So this is like bulk, in bulk you will send this notification. Or things like if again, if a match is starting, cricket match is starting, or a football match is starting, Zomato can send notification that enjoy match, have pizza, things like that, and we see those kind of notifications very frequently. So you can say cluster of those users are with you. You can use query to get those kind of users and send notification. Then finally you should be able to serve it as API. By API I mean in companies like Amazon or Flipkart. So basically you are having multiple services who wants to send notification to their users, right? For example, an order service wants to wants to notify their user that what is the state of their order whenever it is changing. Or you can say authentication service wants to send notification if they want to notify their user that we saw an a new login from a location where you normally do not log in from that system or that location, so is that really you, right? This kind of notification. So these different services should be able to use this service as an API, right? So this can be an out of the box service which multiple clients should be able to use. And finally, yeah, like I just said, it should be an out of the box solution. It should not be like tightly coupled with your main service, right? So these are your functional requirements which we are going to cover today. Then in terms of non-functional, again, you will have things like high availability for sure, because if you are saying you are making an out of the box solution, and that means many services, many customers, clients are dependent on it, then it should be highly available, right? The downtime should be as low as possible, right? Then there can be things like reliability, which I haven't wrote yet. So reliability in the sense, if a service already gave you the data, right, that you just notify this user with this content, and if you return that okay, request taken, then they are relying on you that ultimately you will deliver it. So whatever policy we will define, like for example, we will define a policy that 99.99% notification will reach user at least once, right? If there are multiple devices, then one of the device will receive it, or one of the mode like SMS, email or WhatsApp will receive it. Then we should honor that. So in those terms, they should be highly reliable as well. Now move on to high level design. Basically I'm not going step by step. I'm going with the best design I am having, right? There can be multiple designs, and I will talk about it, what can be a smaller version of it, you know, or a concise version of this design. So I'm moving on to the design now. Do not get overwhelmed with the design. This can be a very small concise design as well, but in a bigger place where we have a very big scale, these are the ultimate things which you will need to design a notification service. That is what I thought about. Let's start with the very start. Basically, let's suppose you have multiple clients, and this I'm not talking about end users. I'm not talking about someone who is using your app. I'm talking about your for example, your order service, your authentication service, the example I gave earlier, right? Or other services in your org, or external customers, for example, right? Those will send you the data, the content. They will hit your API. So this is, I'm talking about notification service as an API, where you gave them the API and they are hitting your API with the user details and the content and all those things, right? That send this notification to this user. So if my client base is very high, if my request number is very high, then I will have a load balancer, and this will obviously to do multiple things. One is to balance load, and in case I am having a global product, then I have to reroute them to proper that particular specific reasons, because there can be like SMS vendor which will only work in India, right? So you want to redirect the request where you want to send an SMS to an Indian user to a service which is actually in that particular region. So there will be a load balancer to manage all those things. Then ultimately behind this there will be a notification service. So treat it as your API server, where you are actually having the APIs. And obviously this is not one single server. Everything here, whatever I made as a service or independent box, is again this is a cluster of multiple things. So you can scale up, scale down individually almost everything here. And I will talk about the services where we cannot do that. So treat it as there are multiple notification services, and load balancer is managing whom to send request and when to which one is basically serving this particular request. Then one notification service will do, it will take all the requests, and there can be very basic you can say authentication and the correction. For example, if you are checking that user ID is null or content is wrong. All those very basic filter can be there. So from here itself you can discard some of the requests which are not valid. Then I'm going ahead with an asynchronous system where you will feed all those requests into a Kafka. So by Kafka I mean basically a asynchronous system, right? So here you can have different topics. So in a Kafka, obviously there can be a topic with high priority notifications. Then you can have low priority or promotional, you can say promotional notifications. Then you likewise you can have different categories, right? So there can be different topics in this cluster. In place of Kafka, you can use, if you are on Azure, you can use Azure Service Bus as well. All right. So you will likewise you will define different queues, different channels for different kind of inputs. I'm going ahead with Kafka because this is very famous in the community compared to other services which we are having. Once it is in Kafka, then you will have different subscriber to these topics, right? So just after Kafka there will be you can say I am talking about the priority service, which will define the priority of users. So it will take basically, so here I talked about the channels, but those will not be high or promotional. There will be different kind of topic if you want, or they can be just load balancing topics, right? Multiple topics and multiple services are basically reading from those. High priority service, priority service is what which will do this categorization. Which one is high priority, which one is zeroth highest priority, low priority, or some other channel, right? It will actually bombard to next Kafka, which will have this high priority topic, low priority topic, mid priority topic, and others, right? Likewise, and tomorrow you can add some other topic as well. So that is why it is like a pluggable system where you can add a topic and just feed into that topic, and rest of the thing will work as it is. So this priority service, on basis of now how this service will define priority. This can be you can say inbuilt, you can say within this service you can have a DB or a configuration where you will define that if this type of topic, if this type of a content is there, then this is the priority of it, right? So it is kind of a flag or a signal which your client will send you, which this understands obviously already, and this will use that to categorize it. Or what you can do is you can have an external cache or a fast DB here to support this kind of a thing, where basically you will read from the DB, and on basis of this you will decide what is the priority and ultimately feed it to the correct topic, right? Then once it is in this topic, then assume that behind it we are having a main, you can say notification handler service, and obviously there will be multiple instances of that notification handler service as well. So on basis of different topics, there can be different notification handler services, which is like high priority notification handler, low priority notification handler. So these are like worker roles, you can call them as workload, worker role, right? Worker services basically. So which subscribe to these topics, receiving the data. Now after this, like I talked about, that you want to rate limit so that you do not bombard your users, and also you do not overwhelm your you can say notification handlers like SMS handler, email handler, and these things. So you want to rate limit, like if your SMS handler is having a limit of that it can send 1 million SMS in a minute, then if you receive 3 million requests, then you have to rate limit, because ultimately you will overwhelm your SMS handler. So those kind of rate limit, everything will be there. Now normally rate limit is always it is like an external external support to your system, where rate limit is a service in itself. It is having a design, and we can discuss that. So think of it as a, another box which is having its own data, to decide that for this user these many notifications you already sent in a day or in an hour. So it is already having all those tables somewhere to support it and to decide basically whether to give green signal to this particular request or not. So notification handler will send it to rate limiter, and rate limiter will ultimately give you a go ahead on whether to ignore or go ahead. So as whenever you will receive this request, as per that you will take a decision, and you will go forward. Basically you will send it to your final Kafka cluster. Now this notification handler is obviously it will also do one more thing, is that it will first is gather user information. Sometime it is like your services are simply saying that to user XYZ, where XYZ is the ID of the user, send this content, whatever is my content. Now this maybe is not even telling you whether to send an SMS or email or WhatsApp. This is like you already have the info of the user in via user profile service, right? So you decide that what basically user is having is using to read notification, right? So that is why this notification handler will connect to your you can say user service to get the info about the user. And then also there will be a separate DB, so it can be a SQL DB which will have preferences like some user prefer WhatsApp message, some user prefer in-app message, or some user want to block SMS, that don't send me SMS anymore, right? So if you have that data, so this preference service will utilize that data to channelize that notification request into a particular cluster, right? And in cases if you have to send to one user into multiple channels, for example you want to send SMS and email both for the same content, that also you will decide here, and likewise you will add it into two topics further on. So that is what it will decide here, and then ultimately it will send this to our final Kafka cluster, which can have multiple topics. Again, one is like for my email there is one topic, my SMS there is one topic, right? For my WhatsApp there is one topic, and in future, for example, if you get IVR, that call the user to give this OTP, right, then there will be another topic for that, and then you will just simply add another service for IVR, and it is kind of a pluggable system again. And individually you can scale all of them. Means if one IVR is not good enough, you can add another IVR, right? Multiple IVRs, and all are subscribing to the same topics. And in fact you can add multiple IVR topics also. Like for email also you can have different topics for email, email 1, email 2, right? And likewise you will divide in different services also. So here now I'm thinking of having separate handler for separate kind of notification modes. For example, for SMS this is a separate worker. Again, this is nothing but a worker, right? A service. So this is subscribing to SMS service, right? It is basically SMS handler will subscribe to this. Whenever data is coming, it will basically send the data via whatever SMS vendor we are having. So we are having different vendors, and there are different ways to talk to a vendor. For example, in some cases you can have an SDK, right? In some cases you will have an HTTP way, where you are sending an HTTP call to that particular vendor, and rest of the things it will take care, and it will give you the status. Sometimes they send 202 because obviously asynchronously they are sending the SMS, or sometimes they also give you 200, but it is complicated, but that's okay. So I'm just saying there can be different ways for different vendors. You are whatever, and you can have vendors on basis of the region also, like I talked earlier. Obviously if you want to send a notification in Singapore, there will be a local vendor only. if you want to send a notification in India, so you will use a local Indian SMS vendor, right? So yeah, so there will be different this thing which you will handle via these handlers. Same for email, you can have different vendors to send emails. Then for in-app, there are for Google, you can say for Android, Firebase is one. Now Google moved to Firebase. Earlier I think there was the different one. And for Apple, it's APNS, Apple Push Notification Service is provided by Apple, which is being used to send as notifications to in-app, right? Now this entire thing is basically happening asynchronously. By asynchronous we mean we sent everything to this Kafka, and we are not having another DB to support whether what is happening to that SMS. Means we could have had something like there is a DB, this thing will feed into this DB, send it to this service. Now service will update the status to that priority is happening, then it will forward it to the next service, and next service will change the status. We could have done it likewise, like that way, but I'm not using any DB. I'm going with these clusters, and all those clusters are always having those events. For example, if a priority service goes down and if it is not being served, so whenever priority service next priority service will come up, all those events will be fed to that particular service, right? So I'm going with that approach here. But finally, when you are going with this, you need some kind of the data, what exactly happened to with notification, or what all things you already sent, what kind of data you processed, to which user you sent what. If you want to send if you want to create that kind of report because of any reason, right? So we will have another in parallel, a tracker, I would say, where this Kafka is actually feeding everything into this, and this we are ultimately dumping into a DB, and this DB you can use to generate any kind of report. For example, a Power BI report, right? Or some other report, right? So this is like you're continuously feeding into it. Now why Cassandra here and why SQL here, I will actually prepare a different video on it, that how to choose the database, but for here, like why we chose MySQL here is because this is kind of a data that for this user this is the preferences, for this user this is the preferences. So it is a relational kind of a data. On basis of user ID, we will actually query things from here. So it will obviously it will give a better performance. Now in case of this one, what we are thinking here is this is a growing data. It is like notifications will come continuously, and you have to dump the data here. So Cassandra we normally use when we have a growing data, right, which is like ever growing, and I'm not thinking of whether it will perform better on query or not, because I'm talking about reports. So it is not like you are querying anything from this DB every second or every minute. This is like once in a week, once in a day, or once in a month you will query, which is obviously any DB will perform in that. So Cassandra seems to be a good fit in this one. Now this is the first design where I talked about using it as an API, as a service which my clients will use. We also talked about one other thing called bulk notification. So there will not be major changes in terms of when we will talk about the bulk notification. Let's just see. So if you see, rest of the things from here onwards is same what we discussed already. Nothing different in this one. The only thing we are changing here is, now like I gave you the example of bulk notification, is like if a cricket match is starting or a football match is starting, and you want to notify your user, for them to pull to your platform that hey, come here and watch the match, it is going very well, blah blah blah. In that case, an admin will start that query. a data admin basically. So he will have different means to do that. So admin, again, it depends on whether you want a load balancer or not. It depends on how many number of requests you are having, right? How many number of clients you are having, admin clients, right, to send bulk notification. So this you can omit or you can keep, it depends on the scale. Then you will have a thing like a bulk notification service. What it will do is it will take the request, and before it sends the request to Kafka, it needs to do that filtration to whom I should send. So if so it will have I'm not going into deep into a search service, but think of a search service where you will say, give me all users who from this platform who are basically active cricket, interested in cricket, right, who watch cricket on our platform. Or give me, for example, in case of Zomato, yeah, again, give me active users who are interested in football. So I will send them a notification to buy a pizza because a football match is going on and they are obviously watching it according to you, right? So a search service will be there. You can have Elasticsearch, blah blah blah. Obviously we are not going, we are assuming that service is already there. Once you will get it, then rest of the things are same. Treat it as like now you have 1000 users whom you want to send this X content, right, or a notification. So you will bombard it to Kafka, and rest of the things is as it is. It will be able to handle it, right? So this is same as above. Now one more thing I should talk about before I close this is, here I thought about that at every point you are having a huge scale, right? Like I'm having different SMS handler, email handler, in-app notification handler, and also like your rate limiting is a separate service. User profile mostly will be a separate service, right? Priority separate service. When you are starting, if you are using this to create your own notification service, some of the things you will always start with that there will be one. For example, in starting you will have only one handler, right, where you can write code for all the three. So there will be different three classes which will be able to handle, one will handle SMS, one will handle email, and one will handle in-app. And also for Firebase there will be separate, and for APNS there will be separate. No need to have different physical servers, different physical workers for it, right? So in starting you can have one. In fact, yeah, there will be vendors, but again you can hit all the vendors from same worker role, right? Your same service. In fact, your rate limiting and your notification preference can be, your rate limiting can be inside this itself. If it is not a, if your you can say the scale is not that much, so you can have these things inside one box. Your priority and your notification handling can also go in one, right? So here I elaborated it into separate services, because ultimately we are thinking of at every point I will have a very huge scale, right? So that is why having separate service is always a good idea, because you will be able to scale all of them individually, depends on your traffic. For example, like maybe you had SMS where you were sending 5 million SMSs in a minute, but going forward people are maybe not relying on SMSs, and you created a WhatsApp handler separately, and suddenly traffic is dropping here but traffic is increasing here, right? So you will be able to scale it very easily, and you can downgrade it very easily if you are having separate services, right? But if you would have had everything into one, then you have to scale the same machine, you can say a horizontal scale of the same machine, but here you can scale that particular part. So this will be way better in extending plus managing the load properly. Yeah, I think this is about it. One thing which I haven't talked about, which I'm thinking is evident from it, is how you will do things like when I'm using a app like Amazon, for example, I'm hitting something, it is hitting a service, Amazon service, and on that server wants to trigger you can say on basis of my transaction, server wants to trigger notification. So those things can directly go to this Kafka. So you can think of, if you are having user transaction, so you can feed those transaction here directly, and on basis of it, it will basically trigger the notification from here, because yeah, it can handle those transactions directly and send it to priority queue, and on basis of the content, it will decide the priority and will take it forward from here. So yeah, that's it about this design. In future, I will in fact try to make a video on all the famous designs we are having for interview purpose, and also if you are trying to make your own service from scratch. So thank you very much, guys. Take care. Bye bye.